All right, guys, welcome back to the Cornfield Customs channel. This week, I'm going to be back on the 1940 Cadillac LaSalle chop. And in this either episode or this small series that I'm going to continue doing on this car, this week we're going to focus on getting the excess material trimmed out underneath these new catwalk pieces I've made, finish planishing this out, removing the factory lead seam where the quarter comes up and meets the old catwalk, and we're just going to keep plugging away on it. So stick around in this episode and check out the progress. All right, so here on the driver's side of the car, this is where the factory lead seam used to be, where the quarters came up and met the old catwalk, and this is what it looked like before. And it's just kind of a mess, and it doesn't really need to be there since we're going to metal finish everything out and we're building a new roof, trying to make everything a lot better. So I just went ahead and replaced this side, but I'm going to show you on the other side how I went about that. So what I've done is I've already applied Dicam layout fluid. That's all the red stuff you see here under where all our panel seams are going to be. That way when I make a scribe line, it'll be a lot more visible. And like I've talked about in the other videos, we're trying to reduce our margin for error and dial back everything. So instead of using a Sharpie, I'm going to use a scribe here. That way my cut line is that much more precise. And I can focus on getting that weld seam super tight, because the tighter and more even the weld seam is, the better it's going to weld and the least amount of warpage you're going to get. So I'm going to grab our piece that goes here, the scribe and a clamp, and we'll get this laid out to be cut and start fitting in our new piece. Here's the new patch that I made. It's a pretty simple patch, and I just used the planishing hammer to raise this a little bit. I put a contour gauge across the catwalk to the top of the quarter to get the radius that we needed, and I hammered that up with the planishing hammer to get that to match. And then I turned our edge here that will come over into the trunk opening or the drip rail area just a little bit. It'll help hide the seam, and it'll help make this edge stronger to prevent warping, and it'll cut out some of that old seam inside the trunk as well. So what we're going to do is we're going to line this up to where everything fits as it should have been on the pattern, and I'm just making sure everything touches and looks good. So what this is I'm going to clamp this in place. But you don't want to just put your clamp directly on the sheet metal. Even though this clamp has feet, these feet can dig in and put a dent in your panel. So what this is just a piece of 1/8 inch UHMW, which is ultra high molecular weight. It's like a plastic Delrin. So I've got a whole box of these that I cut. And what we're going to do is we're going to put that on our panel here. That way it gives us an additional layer of protection to keep from denting our new panel. So make sure nothing really moved. Get it where we want it. All right, so that seems pretty decent. Trying to get everything squared up to where I left a little bit of a gap here where it meets this new catwalk transition piece. That way, as kind of everything comes together, when the underlying metal's cut out, it'll close that gap up. So I'm just making sure that that's nice and consistent. We're touching here on the corners, and as that comes down, it'll move inboard slightly as well. So we'll grab our scribe, and we'll come in and we'll run that right up against our new panel to give us our cut line. So now we can pull that off, and you can see our scribe line. I got a little off there on the second pass, but I'll cut to the inside of that, and then we can file up to that. So if you get off, excuse me, if you get off a little bit on your scribe line, it's okay. Just error to the side that's closest to the middle, and then you can file up to that and make sure that it's going to fit. That way you don't get carried away and cut to the outside of the line. So from here, I'm going to go ahead and scribe some of this line as well for our new transition piece from the catwalk into the roof. That way I know where our cut line needs to be at the top of this patch. I don't really need to have that there because all of this is going to come out, but it's just better to go ahead and cut that so we know where it's going to fit, and we can just remove that section, have it out of the way, and everything's going to be good. So after I scribe this line, I'm going to pull this piece off and set it to the side while we work in this area, and then we will cut and get everything fit nice and tight in here and get it ready to weld. All right, so I've got our new transition piece removed, our line scribed here, so I'm gonna start cutting this out. And what I like to use to cut stuff out that's hard to get to, like I would prefer tin snips, but in this application that's not really gonna work. It's either a toss-up between a real thin cutoff wheel or like an air saw. But since I have good access here and the turns aren't super drastic, I'm going to start off with the cutoff wheel, and I like to run them on a 90-degree grinder. That way I can support it really well with my hand and I can see what I'm doing. So that's what we're going to cut it with, and I'm going to wear a respirator just because I'm real sensitive to metal particulates after being in this industry for a really long time. You know, grinding and cutting and sanding and stuff really affects my lungs at this point. So I always wear a respirator when I can, and I'll wear hearing protection as well because I'm already going deaf. So I need to protect what little bit of hearing I have left. So I'm gonna get the airline hooked up and we're gonna get to cutting. So I have the opening rough cut out. You can see I cut everything with the cutoff wheel, and then I came back here in this radius just with a roll lock disc and kind of ground up to that inside line. You can see that I left my scribe line. That way I can file or sand up to that line and ensure a nice tight fit. So the next step from here is I'm going to add a little more die-chem. I didn't realize I missed it down here. I'm gonna put some more die-chem here, and then I'm gonna work on getting our panel to fit all of this, and then I can scribe that line where our cut seam's gonna be inside the trunk drip rail as well. So I'm going to get that die-chemmed and start fitting the panel and making sure that our weld seam stays as tight as we can get it. All right, so our die-chem is reapplied and it's dry. So we're gonna get this kind of laid over. I'm gonna use this clamp with feet here. Just kind of bridge our opening, our seam there. Make sure everything's tight where we can. Try not to move the camera on you guys too much. So it's a little snug in a couple places. So we're going to rescribe a couple small areas that just need some attention. So with our scribe, I'll just come in, rescribe where it's a little tight, which we knew was probably going to happen because we cut to the inside of our line. And here there's just a little part that's touching, so I'm just marking where I need to file a little bit. And then I'll come in here with our scribe with the 90-degree hook on it. We can scribe this line. And what I'm doing is I'm holding it up a little bit like this. That way our cut line is above the actual seam. And it just gives us a little bit more cushion. That way we don't cut too much out and have to deal with a big gap. I'd rather it be a little too tight and spend a couple more minutes filing it than have to either make a secondary filler panel or fill a big gap. All right, so we'll take the panel off. We'll come back. You can see that we're not heavy by too much, almost just a little bit thicker than the scribe line itself and then those couple spots. So I'll go ahead and I'll probably use the grinder on these, and then I'll go ahead and cut this out with the cutoff wheel. So after I came back in, I filed the edge, cut this out. It was a little bit of a trick to kind of get in there with the cutoff wheel, especially with the camera and tripod being right here. So I opted to switch over to the air saw, but I used the cutoff wheel just to plunge a slot so I could get the blade in there. So I trimmed that out, and now it's gonna be kind of a repeat process until we get it fit right. So I'll grab the piece, we'll test fit it, make any notations of where things need ground, filed, fit, remove it, do what we need to do, put it back on, and it's just gonna be back and forth until we get it to fit nice and tight. So it's not the most exciting process, but it is part of the process. And it's one of those things you can't rush. Like, you don't wanna just get carried away and open the opening up too much to where the panel is loose in there, because when it comes to welding, the tighter your gap is within reason, like you don't want it to be so tight that it's pushing and bellying up or down, but you want it to be nice and tight and even. So if you have, say you have a weld seam that's nice and tight and then gets big and kind of medium and then back to tight, what's gonna happen is you're gonna have to focus more time in that area, and you're gonna add more heat and more filler rod, which is gonna expand differently. So you're gonna get nice, even heating and drawing, and then you're gonna get to that spot and you're gonna spend more time, and it's gonna warp more where there's an air gap. So you want all of your edges to be as tight as humanly possible. And the critical thing is humanly. Like, it's gonna happen, there's gonna be spots where the weld seam's not tight, because we are human, not everything's gonna be 100% perfect. But you wanna do your best to get as close to perfect of a seam every time as possible. And that goes back to the repeatability. The more repeatability you have, the more efficient you're gonna be, the better the weld seams are, the least warping you get, you're gonna be faster, it's gonna be easier to metal finish your parts. So all of this stuff of just doing everything the same way, within reason again, because you always wanna be doing your best to try a little bit better on the next part. So, but you always wanna be striving for that perfect fit, perfect finish, perfect trim every time. That way it narrows that margin of error. If you're always shooting for perfection and you fall short, which is gonna happen, at least you're closer to that line. If you're shooting for 50% and you fall away from that line, then you've got a problem. So always shoot to do your best work and land on that point every time. And that's how you're gonna grow exponentially as a craftsman, because you're always pushing yourself to do a little bit better and a little bit better and hit that mark every time. That's how you progress in this craft, is not just cutting it short, not good enough. You always wanna be pushing a little bit harder to do better and to land on that point, and then you can continue to narrow your margins of error down, and you can really refine and hone each specific part of this process. So that's enough of me jabbering for now, and I'll get the part and we'll get back to test fitting it. So now we have everything fit up pretty decent. There is a little bit of a gap here, which, like I said before, it just happens sometimes, but it's not that big of a deal. But I would have preferred it to be nice and tight like it is everywhere else. So that's just gonna cause me a little bit more work with the finishing, but it is what it is. You know, you can't get hung up on the small stuff. All you can do is hope to do a little bit better on the next one. So our edges look nice. You know, everything fits pretty good. Like I said, it's a little bit of a thicker gap than I want right there, right here in the radius. But it happens. Here, there's still a little bit of overhang, but what I'm gonna do is I'm gonna go ahead and get this die chem cleaned off, and then I'm gonna tack this into place, and I'll finish this on with it tacked in. I can take our cutoff wheel or our air saw, and I can come it at a 45-degree angle. I can make that cut using one piece as our guide, and then as they come together, it should close the gap up nice and even. So I'm gonna get the die chem wiped off, everything reclamped, and we'll get to tacking. To get the die chem off, I'm just using some run-of-the-mill lacquer thinner, acetone will work. And I'm just gonna pretty much wipe it off right where we're gonna be welding. I'm not gonna wipe it all the way off across the panel. And you can see just the heat from the cutoff wheel, it's kind of baked it on. So just want to make sure everything's as clean as we can get it. Just so we don't get the die chem to contaminate our weld or anything. All right, so with it clamped back in and the die chem wiped off, you can see just that little bit of gap I was talking about. I mean, it's not even the thickness of my fingernail, but again, if you sweat the small stuff, it'll make you better in the long run, just so you can try to be better next time, but it's not the end of the world. So I'm gonna set the TIG welder up, and we're gonna come in and we're gonna tack this into place along the top here. Even where this seam's gonna be cut out later, I'm gonna put some tacks here just to help hold everything nice and flat, and I'll get it hammered and dollied out. I like to use the TIG on sheet metal just because the TIG is it's a cleaner weld, it's more focused, you can control your amperage and your wire input better, as well as it's more of a soft weld compared to like a MIG weld. An oxy-fuel weld is a nice soft weld as well, but I prefer the TIG welder on sheet metal, especially when it needs to be finished out really nice. You don't have to TIG weld everything, but if you work on becoming proficient at TIG on sheet metal, it's just going to take your work to the next level, which I think is kind of the name of the game. You always want to be getting better, and you always want to be pushing your quality higher and higher. So we're going to come in. This material is about 19 gauge, so I'm going to probably set the welder at 50 amps. Ballpark rule of thumb, I've mentioned in some welding videos, is you want 1 amp for every 1/1000th of material. So 19 gauge, it's right around 0.43 to 0.46, give or take, depending on what mill it made and what their tolerance is. Plus this is old sheet metal, so it's probably been ground on, some rust. So 50 amps will give us a good baseline to start with. And I'm gonna be using 030 filler rod. And we'll come in, like I said, we're just gonna tack everything, and then I'll come back and I'll hammer and dolly it out to get it nice and flat. So the key with TIGging your sheet metal, especially when you're tacking before you hammer and dolly everything out, is you wanna use as little filler rod as humanly possible. That's why I use 030. If you're using like a 16th or a 3/32 rod, you're gonna have a lot of buildup of material. So then when you hammer that out, your tack or your weld is going to be proud of the parent material, which you're going to be stretching that and can cause warpage before you even get this panel fully welded. So use as little bit of filler rod as you can get away with, and then when you hammer and dolly it out, your panel should be flat without any grinding. There's always going to be a little bit of dressing at the end that needs to be done, but especially when you're tacking. That way you don't have to grind your tacks down, which could dig into your parent material and make things thinner. So as little filler rod, especially on tacking, that way you can hammer it out, everything goes nice and flat, and you don't have to do any grinding. So we've got the welder set up, 50 amps like I said, electrode negative for TIG, everything's set up on the remote, and I'll hit the pedal here. And we're running about 15 to 17 on our CFM gauge there, and that'll get us what we need. So on our TIG torch, running about a 1/16 tungsten, and it's a nice sharp point, and I think that's a number 8 gas lens on there. So we're ready to get that tacked in. So we're ready to go, got our 030 filler. So if you can, you want to fuse tack it without adding any filler. That'll be possible in a couple spots, but some spots we won't be able to because of this gap. So I just keep the filler rod close just in case it doesn't fuse, so we don't spend a lot of time introducing heat or burning a hole. So let's get to tacking. So it's mostly tacked up. Right here, as I tacked, it kind of drew a little bit, so it's snug. So I'm gonna come in with the hammer and dolly and stretch these welds up a little bit, just to see if it opens that back up to give us our fit that we had before we started tacking it. And if you notice while I'm tacking, after I stop the tack, I keep the filler rod and the cup over the tack for a few seconds to post flow that. That helps keep any contamination off of the tack and the parent material while it's still hot, as well as the filler rod. So it's a good idea to get in the practice of keeping the filler rod in the flow of gas until everything cools, so you don't get any contamination on the end of your filler rod. Got our hammer and dolly here. I had to move the camera a little bit so I can get in here, but we're just gonna stretch this weld out a little bit all the way around. Just focusing on the tack itself, because that's the only thing that changed, is we just introduced a little bit of heat where the tacks were. That's the only thing that changed. So we don't need to be hammering out in here, just where the tack contracted as it cooled. And I'm just kind of moving this, there's a wire hanging under here and I'm moving it out of the way. So just that little bit of hammer and dolly work flattened everything back out, and I'm going to continue tacking down. We may have to stretch the weld out when we put a tack here, because when I hammered here, it opened it up to there, and it's still a little tight there where it's drawing down, so we might have to work that out as we progress down the seam. Now with it all tacked up and hammered out, I mean, it's pretty smooth across. So once we weld all this up, we'll just come back and do the exact same thing. But before we do that, I'm gonna come in here and I'm gonna finish fit inside the seam, and I'll go ahead and get that trimmed, tapped in, and everything nice and tight. And then we're gonna move on to welding, which is always one of my favorite parts, especially showing people how I like to weld things, because it's kind of backwards what most people think. When you're using MIG on sheet metal, you want to do kind of what we did here, tack it, then you're gonna have to grind it, which is different than the TIG, and then hammer and dolly it, and then come back, tack in between those, grind, hammer and dolly, tack, grind, hammer and dolly. It's a very slow process, and a lot of times the weld can crack because a MIG weld is harder than a TIG weld. So the thing that always blows people away is that when we start welding this, I'm going to weld from start to stop at each line with this, you know, try not to stop, but on, you know, something say 6 feet long, on like a quarter panel, you're going to have to stop. So you want as few starts and stops as possible. And my reasoning behind that is I've talked about in other welding videos that even heating is even cooling. So you get, we'll just say that it's already tacked together, hammered and dollied out. You get a bunch of little stitches. So you get hot, cold, 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 all the way down the panel. And the warp is going to mimic that. So you're going to get a bunch of little waves all throughout the panel that come across. Or you can weld it in one shot and you're going to get hot, cold. You're going to get one long continuous heat cycle of everything's going to heat up the same, it's going to come across, and it'll contract the same. So for me, it's easier to correct that weld because you don't have a bunch of different heat ranges or heat cycles that are creating the different waves. It's one giant heat cycle that usually makes one continuous warp. So for me, it's a lot easier to correct, and that's why I do the seam one shot or as few starts and stops as humanly possible. So give it a try. You might like it, you might hate it, but if you're doing TIG only, don't do this on MIG, but just give it a shot. Try it one continuous weld and then try it in stitches and just see which works better for you. Because that's the big thing about metal shaping is there is no one right way. You have to figure out what works best for you and the way your brain interprets information and your skill set. So try things different ways and see which one works best for you. Again, there's no right or wrong way as long as you're getting high-end finished parts with no bullshit. You know, that's the big thing is you don't want to be saying that, you know, I built the back half of this car in 8 hours, it's flawless, metal finish, no filler. Just live in reality. You know, things take time and there's always going to be a little bit of filler here or there. So try things different ways, be realistic with your expectations and the process, and just work through it. So I'm going to go ahead, get this trimmed up, fit, and we'll get it all welded up. All right, so this is a good stopping point just to talk about something interesting that kind of ties everything together with some of the other videos. So I've talked about distractions, and of course, a big distraction came right as I started this weld. So I'll turn the camera down. You can see that I made it about halfway through, and somebody was at my front door ringing the doorbell. So I'm like, well, I'll let it go. And they just kept ringing the doorbell, ringing the doorbell, ringing the doorbell. So I'm like, well, maybe it's an emergency. So I went up, and it was FedEx. So that's how it always goes. When you're doing something important, that's when the distractions come. So it's always a good idea to eliminate or try to eliminate every distraction you can, especially when doing critical things. So this is going to be a good learning point because I'll show you the weld up close after I finish this one, and you'll see how nice and consistent it is. The heat affected zone is nice and consistent, but then where I start, the heat affected zone is going to dip in and dip out. That's because that's a different heat cycle. So that will have an extra warp there, which we can correct. For me, it's just a little bit more work. So as bad as it was that, you know, I had to stop and go up and answer the door, at least it happened while I was videoing, and I can use it as a teachable moment to show you why eliminating distractions are good, and then what happens if you can't bypass a distraction or you start and stop in a weld seam. So let me get back to welding, and then we'll do a close-up of it. It's all right, here's a close-up, and it's funny, we were just talking about distractions. I got off, kind of off topic and wasn't paying attention and just started welding, and I was gonna weld this whole seam up because I got pulled away from my concentration by having to answer the door and go through all of that. So another good reason why it's good to eliminate distractions, because you get pulled away, off topic, you kind of forget where you are, what you're working on, and like for me, I see a weld seam and I just weld it up even though I don't need to weld this one because that one's going to be cut with the other panel. So kind of sucks, but at least it's something easy. So with what I was talking about, here you can see that was my first initial weld, and that's where I had to answer the door. You can see it right there as the heat affected zone kind of tapers down and then it gets big again. So this inconsistent heat cycling here is going to be an additional warp. Versus this one, you can see where I started. It's a nice, consistent heat affected zone all the way down. And one thing on this note, I'm not looking for rows of nickels or anything like that because we're gonna hammer it out, so it doesn't really matter. As long as it's good penetration, very little filler rod, just enough to be slightly proud of the parent material, it doesn't matter what it looks like as long as it's a good weld. So there's our piece, and it's all welded up. So from here, I'm gonna start to stretch that back out with a hammer and dolly. All right, got my hammer, got my dolly. I'm gonna climb into the trunk here so I can get easier access to this, and we'll start stretching this up and just focusing right on the weld itself and the heat affected zone, and just start bringing that up and working the weld back into itself. All right, most of the weld seam is hammered out. It's a little wavy here in the middle, which I'm gonna get to later, but right now I just wanna check where our weld seam is. So one good way you can do this is if you get a piece of 1/16 TIG filler rod, you can just kind of loosely hold it over where you're working. It'll show you any low spots or high spots as it kind of pulls away. It's not telling us any real radius or unit of measure, but what it's showing us is that it's just if you have any high spots or low spots next to where the weld seam was, and you can spread that out, and we can kind of do it all the way across, and it shows where the wavy spots are. And it's not bad, it's just a little tension still held up from the weld. So when you're hammering and dollying out your welds, you don't need to be over here or over there, and I try to stay out of the middle of the new panel because it fit decent before. So the only thing that changed from it fitting well to being wavy, other than a little bit of weird pull from the heat, is the weld. That's the only thing that changed. We're just ignoring the waviness, but like the big warps, the only thing that was introduced that changed that was the heat from the weld and the contraction from the weld. So this kind of goes back to what I was saying about even heating is even cooling. This seam is nice and smooth, and you know, looking across this, like I can't feel from this point down to here, it's nice. But here on this one, there's a high spot where it's pulling right through here. And what is also in that high point line? The deviation where I had to stop to answer the door. So you know, that kind of goes back to what I was saying, is that even heating is even cooling, and some of this warping here could be where the heat cycling stopped and it pulled tension inward towards it, and then when I came back a couple minutes later and picked up, it pulled tension as well. So what I'm going to do from this point, since the weld is knocked down pretty good, I can just go over it with some 80 grit on a sander and knock that off. But what I'm going to do is I'm going to take my slapper and this heel dolly here, or some people call it a football dolly. I just call it like a universal dolly. It's my go-to. And I'm going to work this with a slapper around this area, just trying to blend everything out. Again, from experience and kind of feeling, I wish you guys could feel it, but there's like a high spot right here that runs almost right where that weld started and stopped before. I'm not sure if you guys can really see it or not, but working across that, I'm going to stretch that just a little bit more, but other than that, it's really close. So I'm going to hit this with the slapper and that dolly and just work over the whole area, try to blend it out a little bit, and it might overstretch it a little bit, so we might come back and hit it with the shrinking disc just to tighten things up after the fact, just to kind of see where we need to go. And then I also still need to come in and weld inside the drip rail here, but I'm saving that till afterwards, till once I get this area worked out. So I'm gonna get to the slapping with the dolly, and we'll see if we can get that raised up. All right, so I wanted to talk a little bit about slappers and dollies and hammers and their differences, since we were just using both hammer and dolly and a slapper on the Cadillac. So I did another video talking about slappers, so this might be a little bit of a recap or redundant for some of you guys that have been viewing longer, but for the new people, I think this will be great. So what a slapper is it's a striking device similar to a hammer, but it's long and narrow, so it spreads your contact patch out quite a bit. So these are really great for refining surface finish, planishing, raising up some low spots and working high spots down and just blending everything out. I'm gonna do some very terrible sketches here, but we'll say this is our panel, and I'm gonna make this exaggerated so it's easier to see and understand. So we've got some waves in our panel here. So we'll just extend that on forever. So this is our panel. These are our highs, and this is our low here. So if we have a hammer, it has a very small face. It's about 1.25 inches in diameter, but our contact patch is roughly here, about this, maybe about 1/2 inch, 5/8 in diameter. And that's our contact patch. So when then you take a dolly and you put on the bottom of it, the dolly's a lot wider than the hammer, but you still have the same contact patch there. So it's gonna be a lot harder to work these highs down and this low up with having to bump around. So a good trick of that is you can hold your dolly here on your low spot, and you can strike with your slapper here on the top. Hopefully you guys can see that. And it'll bridge those surfaces. So again, this is a very exaggerated warp in a panel or a wavy spot. So it spreads the force out. Again, there's our contact patch on our hammer. The contact patch on your slapper is roughly 1/2 inch to 5/8 by about, this one is about 5 to 6 inches. So it really spreads that contact patch out, and you can bridge across your highs to help push those down while using the dolly to bring up your lows, and it just helps smooth everything out. So there's a lot more that goes into using a slapper and a dolly and a hammer, but at least hopefully this will help explain kind of what I was doing in that small area on the Cadillac. There is, I had used the hammer to focus my contact patch right to the weld seam, stretch that weld up, bring it up, and then we had to blend that out because we had a little bit of wavy area. So we used the larger contact patch tool to help work that entire area as one unit and bring everything up to a smooth surface. So hopefully that's not too confusing, and it explains a little bit of what's going on, how the tool's used. But we're gonna get back to the car, and I decided we're just gonna do one video on getting this piece finished up. So from here, I'm gonna go back. We can sand down our weld seams a little bit with 80 grit, and then we can shrink it with the shrinking disc if we need to, and just get everything finalized, and we'll wrap up this video and just finish up that piece. And then on the next video in this series, we'll get back to the transition piece from the catwalk into the roof, planishing out the roof part, and then I have to make the passenger side rear roof section. So we're gonna get back at it and get this thing done. Now we're back to the car. Everything's hammered and dollied out, and I use a slapper a little bit. There's still a little bit of a wavy spot, but before I get too crazy, I'm gonna come in with a high-speed sander with a DA pad adapter, and I can use 80 grit DA paper, and we'll just lightly sand the top of our weld down, and then I'll kind of go over it all one direction, and I'll come back and we can run the shrinking disc over it just to tighten everything up if there's any high spots or low spots. So let me get the sander, we'll knock the tops of this off, and we'll get going. So this is what we've got. It's a high-speed sander, and I made this little adapter that goes in here. So then I can take a standard DA pad and I can thread that in. And now it accepts an adhesive style DA backing pad, and we can use the same DA paper that I use on our DA for finishing. So this is just 80 grit on a high-speed sander, and we'll tidy this up a little bit. With running the sander over, mainly focusing just on the top of the weld, trying not to gouge the parent material, and then just a quick once over. That way we get a little bit of kind of a texture I can watch while I'm using the shrinking disc. So now we're gonna hit it with the shrinking disc and just tighten everything up a little bit. So for those not familiar with what a shrinking disc is, this is a shrinking disc. So this is one I make, it's a serrated style, and what it does is it uses friction across the metal, and it heats up the high spots, so as they cool, they start to contract. And that will shrink the material and tighten everything up. So it's gonna shrink the high spots, and that'll help pull the low spots up, and you just work this area. Usually about a 12 by 12 is about as big as you wanna go, depending on what you're doing. And just let the disc do the work. I don't like to quench anything, so especially if you're welding, don't quench with air, don't quench with water. Let it heat up naturally, and then let it cool on its own, because what's gonna happen is the molecules are gonna get real hot and excited from welding or the shrinking disc, and they're gonna be moving around, and then you're gonna hit it with air or water, and they're just gonna stop where they are, and it'll kind of harden a little bit, and it'll be stuck in tension. If you let it cool on its own, they'll be all hot and moving around, and then they'll slowly start to slow down, and they'll be in kind of a relaxed state. So personally, I never like to quench anything with air or water, none of that. Just let it heat up and cool down on its own, and you'll get much better results. So I'm gonna work the shrinking disc across this. As we shrink, I might have to use the slapper and a dolly a little bit to adjust a few spots, but let's get to running the disc and see what happens. So I went over this area a few times with a shrinking disc. It's still a little warm now, so I'm gonna let it cool all the way down. But from this point, I'm gonna go back over it with the sanding disc on the high-speed sander and 80 grit. I'm gonna talk a little bit about what I call camo grinding. You see a lot of guys with 36 grit or 80 on like a little right angle air grinder, and they'll do a bunch of little passes and a bunch of little passes and a bunch of little passes. You're masking stuff when you're doing that. You're hiding waves and dents and dings. At least in my eyes, you are. So that's why I call it camo grinding, because you're masking the finish of the panel. So what I'm gonna do is I'm gonna hit this with 80 grit on a high-speed sander, and I'm gonna go all one direction so it's nice and uniform. I can see if there's any issues I need to work out. And from there, then I'll go back over it with 80 grit on a DA, and I'll get all those sanding scratches out. And then I'll come back and I'll hit it with a DA with a red Scotch-Brite pad to really smooth everything out. When sanding, I'm not digging in. I'm just I'm gonna remove the texture from the shrinking disc. And once that's done, that's it. And I'll move on to the next step. We don't wanna thin the metal out a ton. That's why I don't like to use like a heavy Vixen file, because those gouges, I'll show the surface here, but you can see heavy Vixen file scratches where it was either leaded and it was corrected with a Vixen file, or somebody previously has worked out a dent and they filed this metal thin. So at least now the metal is nice and solid, it's tight, it's not springy, and like I said, I'm gonna come over it with the high-speed sander just to get an even texture, and then we'll work back with 80 grit and the red Scotch-Brite. And I'm not looking for metal finished, especially because we're gonna have to come back and we're gonna have to put another weld in here when we put the tie-in piece. So that's gonna heavily affect this area. So I'm not looking for 100% metal finish at this stage. I just want it to be pretty close. That way it's less stuff that we have to deal with later. I'd much rather attack this in stages and get this area nice, then move on to the next one, instead of just having all of this welded together as one unit and then have days or weeks worth of metal finishing everything at one unit. So I'd rather break it up into little mini stages. So we'll get this pretty close, and then when we get the tie-in pieces done, I'll finish that seam, and we'll just kind of work together to get everything welded, finished, and ready to go on the car permanently as we go. So it's not one long, tedious metal finish on every weld seam we have going. So let me sand on this, and we'll work our way up, and then we will call this area done. There's those heavy Vixen file gouges I was telling you about. And you can see that the finish from the shrinking disc, the scratches aren't much. It's more of like a burnished finish. You can see how it was 80 grit on a DA here, and then it's more like a burnished polish. And that'll help show you any deviations. Like here, you can see our light line kind of bow funny. So there's a little bit of a low spot there. But overall, it's pretty decent, especially since we just put that patch in there. So let me get the sander out and we'll dress this up. All right, there we have it. It's still a little wavy, but like I said, we're gonna come in here and we still gotta weld all that. So that'll give us more of a chance to address that, but this is how you check to see how good it is. No, I'm just kidding. Nobody actually does a slap ruler test, but like I was saying, it's still a little wavy, but we're gonna have, 10 feet of weld all the way across, and that's gonna give us a chance to come back and fine tune this a little bit more. So that pretty much wraps up this corner here, and that's gonna wrap up this video. So I wanna thank you guys so much for checking out this video and some of the other ones I've been working on, and I really do appreciate the continued support. Drop me a comment, let me know what you think. Please tell a friend, mention me on your YouTube channel, your Instagram, share our posts, because I really want to grow this channel, and I really do appreciate you guys checking out all my content. So thank you so much for checking out the channel and watching these videos. Hopefully they're insightful and you can learn something, and let me know what you think. And again, thank you guys so much. Please subscribe, leave a comment, and like. It means a lot. And thanks again, and we'll catch you guys on the next one.